Today I'm going to talk about LeetCode question number 572, subtree of another tree. So, given the roots of two binary trees, root and subroot, return true if there's a subtree of root with the same structure and node values of subroot, and false otherwise. Subtree of a binary tree is a tree that consists of a node in tree and all of its other nodes descendants. The tree could also be considered as a subtree of itself. Okay, so for example here we have this tree and then this subtree, and obviously this subtree fits in here and they match exactly the values, the left subchildren, the right subchildren, etc. Okay, so you output true. So this problem is just like another LeetCode problem where you have to figure out if two trees are the same, except with a slight twist. So we'll obviously have a function that will have that's pretty much the same as it is saying that will check if the subroot and starting from this root here and a subtree of this bigger tree, starting from any node here. I will check starting from this node and starting from the subtree's root node if they're the same. Okay, we'll obviously have that function. And in our main recursive function call, what we're going to do is check if the subtree's root node, okay, is same as the current node we're at. If the values aren't the same, then we're going to basically traverse through the root node, until we find a node where the value is the same as the subtree's root node. Okay. And once we do, then we pass it to our is same function. That's basically going to tell us if two trees are the same. And if it is, then great, return true. Otherwise, we'll keep searching. For example, instead of 5, this were 4 here, and these match, this 4 matches this 4, and we pass it to its same function, it's always going to return false because this has no left child or right child. It's structurally different than this subtree. Okay. And yeah, if we do find a subtree, great, we'll return true. But what if we don't? How do we know if we haven't found a subtree in our main bigger tree here? Well, we'll know if we reach all the way to the end of the root node. So no, none here, none. We'll know if we reach the leaf node's descendants, and if we get none, then that means we've gone through this whole entire tree without having found a subtree that's same as this one. Okay, that means for the whole tree, the condition at some point did not evaluate to true, where we found a subroot starting at a node in the main tree. Okay. And that's pretty much how we're going to go about it. And this will be O of n time, linear time. Okay, now to code this up. So what I'm going to do is define our isSame function that our main recursive function is going to use to check if starting at a given node and the subtree's root, if they're the same tree. So let's call them P and Q. So if P equals none and Q equals none, and true. If P equals none or Q equals none, return false. That means one is none and the other is not none. So if one is none and the other is not none, then obviously that means the trees aren't the same, they're structurally different. If P dot L does not equal Q dot L, basically we're gonna turn false. And yeah, I think that's all the conditions we need to check there. Now we can also check the children, but even if we could check the children if p dot right, is none, and p dot q dot right is not none. But I think these recursive cases already handle them. Okay, so what we're going to do is left is equal to is same p dot left, q dot left, and right. P dot right, q dot right. Okay, and then finally what we're gonna return is either if left is true or sorry, what we're going to do is if left equals false, then it's return false. It's not going to be the same no matter what we do. If the left subtree is false, just return that. Or else, return right. Okay, so now we're going to define our main recursive helper function. I'll call this root subroot. So if root equals none, return false. If let's see what other base case is there. So if root dot val equals subroot dot val, then we're going to call is same. Is same root subroot. Okay, and then if res is true, then return res. Otherwise, we kind of want to keep traversing through a tree. Check if any other nodes match the root node of the subtree. Left equals vector root left subtree, and if left is true, we found in that left subtree a match where the root we found where the subtree is a subtree of the main tree. Left is true and true, or else right is gonna be right subtree and right. Okay. And what we're going to do finally is resolve this vector root subroot and result here. Okay. Looks good to me. I'll try running the code. Subtree is not defined. Oh, call it subroot. Okay, I'll try for the rest of the test cases here. Okay, now finally I'll submit. Okay, great. Thanks for watching.